So welcome to the meatiest lesson so far in probability. It's called Venn diagrams. Just so you know, in Danish, the word Venn means friend. So I kind of think of it as friend diagrams, right? So groups of friends, maybe, possibly. Okay, I don't know. So just to kind of go through, we use diagrams to help us with like complicated examples, because especially if you have like a very long problem, it's helpful to keep things visual. So just to kind of go through again real quick, right? Just this is the total number of people. So this right here is like the sample space of the total number of people that we have here, or total number of items, whatever it is. Um, and just to refresh your memory, right? These are only A. This is A here. This is B here, and this is the probability of A and B. That's in the middle, okay? So we'll talk a little bit more about that. And usually in the corner right here, we put whoever is neither A or B, okay? So for example, let's do a problem. If you have a total number, in A only, there's 5. In A and B, there's 3. In B, there's 2. And in neither is 1. So then the total would be, just take those, add them up, and that's going to be 11. So there are 5, that's only A, 3, that's both A and B, and 2, that's only B. That's only taking B. And this can be with like boy, male, female. This can be with English and math. It can be with global and history, right? You can do it with literally any two sets of things that are going on, okay? So just to kind of talk a little bit about the word intersection. So we kind of did this last time. So probability of A and B. So intersection right here is like and. So this is a way to explain it, right? So if you have the probability of A and B, if you have two diagrams right here, right? If I were to go ahead and shade in what is in A, so here's A, so this whole thing right here is A, okay? If I were to draw another one and show you what B looks like, right? So if I have over here, this is same diagram. Here is B, and if I were to shade in B, this right here would be B, right? So think of A and B as where these two circles, where they overlap. And you should be able to see like right in the middle, they overlap right here. So this section right here is where the probability of A and B is, okay? So it's going to be the intersection right here in the middle, okay? These are the overlaps. Does that make sense? All right. So union is basically or, okay? So this is the word or. So union, it's very easy to be part of group A or group B. Okay, so you can be in A or in B. So if I were to go ahead and shade where that is, so the probability of A, right, is going to be here, right? This is the probability of, actually, let me just go ahead and include the people who are here as well, right? So that's all probability of A. The probability of B, let's go ahead with some orange here, is going to be anybody in here, right? Make sense? And then the people who are over here in the middle, they are double counted. So to refresh your memory about what we did last time, so if I asked you what is the probability of A or B, and this is in your formula booklet, that is the probability of A plus the probability of B minus the people who are double counted. See, you can see them here, right? Visually, there's blue and orange here. So minus the probability of A and B, okay? So that is union. We did this last time, so I just wanted to give you like the visual for it. All right. So now we're going to do something that says draw or shade the following. So A, this is, even though we want to call it prime, we're going to call this not A and not B. Okay. All right. So let's talk about what A, not A means, just visually. So if I go ahead and change my color real quick, let's go like a darker blue. So this is A. So if I'm shading not A, right? I'm going to go ahead and shade everything that is outside of A. So all of this, all of this, all of this, all of this, right? You with me? And I'm also shading this because this is B, it's not A. I'm not shading this part because A includes this whole thing, okay? So now if I do the same thing for the second one, which is not B, right? So let's go to the opposite color. So here's B. I don't want to shade that. I want to shade everything that is not B. You with me? Right? Everything outside of this part right here. So all of this. Hmm? I'm not shading anything in B. You with me? So now what I'm doing is I'm looking to see where, this is B, where they intersect, the and, okay? So if you notice, I'm not shading anything in A, so I'm not shading any of this. I'm not shading the intersection, right? Yep, not shading the intersection here. And I'm not shading any of B. So I'm not shading A, the intersection, or B. So what is where not A and not B meet? The only thing I'm shading in both is the outsides. So it would be all of this. Okay? So all the neithers is the best way to say it. Shading all of this. All right, including this part right here. Okay. Um, that should make sense visually. Hopefully this diagram helped you kind of figure this out about how to shade the following. All right, so what is shaded here? So let's take a look at this, right? So it looks like there's nothing of A shaded, there's nothing of the neither shaded. But what's shaded here is, it looks like it's only what's in B. So how do we write this, right? We say, is it anything with A? No, it's not A, and it's B, right? So the probability of not A, and B is what's shaded. So not A, remember, is, and we visually, we drew it, right? Not A is literally everything that is on the outside, and B is this part right here, okay? All right. All right, so let's do a sample problem and then you'll have some time to practice. So in a class of 40 students, as soon as I saw that, I put 40 right here because that's our total. It says 34 like dinosaurs, 20 like Legos, and 2 hate both. They're kind of lame. They hate both dinosaurs and Legos, okay? So we'll go to the question in a second, but let's go ahead and just process this. So I'm going to call these people who like only dinosaurs A. B is going to be who likes dinosaurs and Legos, and C is going to be who likes just Legos. And so we know that we don't know anything about those specifically right now. That's what we have to find. But we do know that two hate both Legos and dinosaurs. So these two are like out here. This is the neither. Okay. So now let's see if we can use what we're given to help us. So they told us that 34 like dinosaurs. So if I were to do this visually, A plus B equals 34, right? Let's do this systematically. 20 like Legos, so that means here's our Legos, right? B plus C is equal to 20. Why did I put that? B plus C is equal to 20. Okay. So I use that, and I use this. Okay. So now let's see what else we know. We know that Hmm. Okay, so if there's 40 altogether and two are neither, they like neither dinosaurs or Legos, then I also know that A plus B plus C is equal to 40 minus this 2, which is 38. All right, so now it's just a bit of like a little bit of substitution here. So I know here that B plus C, right, this together equals 20. So I have A plus 20 is equal to 38. So let's see if we can find out what A is, right? Subtract 20 from both sides and I get A is equal to 18. All right, that's helpful. It's like a puzzle. You're a detective, okay? So now we can figure out B, right? A plus B equals 34, so this must be 16 because 18 plus 16 is 34. Now we can use this piece of information, right? Let me just go ahead and be specific here. I have 18, which is A, plus B, which I didn't know is equal to 34, and I know that B is equal to 16. Okay, I didn't want to just say it and not write it down for you. All right, and now to find C, I know that B plus C is equal to 20. So I know that B is 16, so 16 plus C equals 20, which makes sense that this is 4. So now let's check our math, right? 34 like dinosaurs, 18 plus 16. Boop, right? Double check. 20 like Legos, so B plus C is 20. Okay. 2 hate both, we have them accounted for, and the total is 40. So let's add 18 plus 16 plus 4, right? That's 20. Uh, 18 plus 2 is another 20, so that's 40 altogether. So now it says how many students like both dinosaurs and Legos, and that is this middle piece right here, so that's 16 students. Okay, all right. So now it says what is the probability that a student likes dinosaurs given, okay, so probability that they like dinosaurs given they like Legos. So remember our formula for that, probability of dinosaurs and Legos over the probability of the second one, which is Legos. So now it's just a matter of plugging in, right? How many students, what's the probability of liking dinosaurs and Legos? 16 out of 40. So I'm going to do 16 out of 40 here over the probability of liking Legos is going to be Legos altogether is 20, right? So I have 20 over 40 over here. This goes into our calculator. That's not our calculator. This is our calculator, right? This goes into our calculator. I'm just going to show you how to do this. So alpha y equals option number 1, right? And then now I want to put another fraction here. So I want to go alpha y equals again, option number 1. And you see the other fraction. So I have 16 over 40 over 40. And then I go to the bottom, and now I want to put 20 over 40. So alpha y equals option number 1, 20 over 40. And then I'm just going to go here and hit enter, and it gives me 4/5. So 4/5 is my answer. Okay. All right. Go ahead and look at the problems that are here. Do these, right? Anything examples, do them yourself. It does talk a little bit about mutually exclusive, and then it gives you some problems. So please do the problems. If you have questions, let me know. All right. Good job.